Alright, good evening ladies and gentlemen. This is the AAMU VEXU Robotics YouTube channel. I am your host for this live stream, Brody, and we are currently on our third CAD stream for V5 and VURC robotic construction. Turn the music up just a little bit more. Yeah, there we go. Alright. So now with that settled, we are going to get started. Last stream, let's go back to what we covered. There we go. So of course we got the pushback game element here. And then, where did the... here it is. So here's the robot currently as we have it. Like I mentioned, probably going to redesign the chassis. For those of you that are not seeing the first stream, this is the chassis assembly that we made. It fits within the base dimensions for sizing constraints, which Vex is going to be going back and clarifying. So let's do... Where'd it go? Nah, we'll just go edit. Yeah, there we go. Alright, so it does fit within the, of course, 18 inches side length, and it also fits within the current 22-inch diameter restriction, because of course Vex has the restriction of in any direction the robot cannot be more than 22 inches, and so it fits within that as well. But Vex will of course be clarifying that in a future update, probably within the first update if I had to guess. And so let me actually go ahead and pull that up and check, because they did address that in the, I believe it was their message to the, or message from the GDC. Let me see if I can pull that up real quick for our, pushback game manual, open with, here we go. Now we're going to go to, where is it? Updates. So possibly looking at, May 27th, so possibly, oh no, that's just when the official Q&A system opens. So tomorrow, that's when the Q&A system opens, and so possibly we will see with the Q&A system opening that Vex will address the 22 inches and an official post. But definitely once we get to June 5th with the minor typographical errors and like the version 0.2 release, that's probably when they will have the 22-inch clarification. And I'm guessing, of course, as I mentioned in the first and maybe the second stream, definitely the first stream though, that the 22-inch extension will probably be in a singular direction from your robot after the beginning of the match course, like in previous years, whether it be over under or definitely last year like in high stakes, or really any previous season. So moving on, of course, like I mentioned, this is the chassis that we had constructed in that first stream. I will of course be sure to either link that in the description or put it in a playlist so that you guys can easily find that if you wish to know how this was constructed. Of course, you can freely skip through that live stream however you wish. And now moving on to the block holding station, or no, where was it that I constructed that? Yeah. So this is the block holding station that I currently have. It can fit 8 blocks here. The idea, of course, it being, and this was constructed last stream in CAD Stream 2, again, will be sure to include a link to that or to a link to the playlist that I'll make with all this stuff in it. So for the blocks course here is 8 that it can hold, but I'm planning on extending into the intake and making it to where it can hold more, because as we've seen recently with certain teams, you can actually kind of passively get the blocks out of the what's it called, out of the loading stations. I'll try to see if I can find a I'll try to see potentially if I can find that video that I should have saved, because there is a passive mech now that teams may be using in order to get the blocks out of the loading station, which now that mech can probably clear out the loading station in about 2 seconds. And so I definitely think that early season you will see teams taking the you'll definitely see teams and definitely skills at least clearing the loading stations, which I believe if you're able to clear the loading stations, that is 20 points. So let me double check that real quick in the V5RC hub app. And if you do not have this, that will be very, I recommend very much that you get it. So loading stations, I believe, is 5 points each. Yeah, 5 points each. So that'll be an easy 20 points that teams will get. And then, of course, if you clear out on top of the 4 loading stations, if you clear out the blocks from the parking station, just on the red side where you load in and get your robot parked in there, that's 40 easy points that I believe you'll see teams early season getting. So that's just driver, of course, and then I think a team can easily get 20 points, 15 points for the park, and then 5 points for the driving station or the parking zone on that red side. So I think you will definitely see teams get 60 points probably early season, and then going into, of course, the later season, you'll see teams start to get the second parking zone, which will, of course, be an extra 5 points. And so that will definitely be interesting to see as the season evolves, seeing how consistently teams can, of course, get the loading stations loaded up. And, of course, the VURC, which is the level that we compete at here for the VEXU Team Bionic Bulldogs here on the AAMU VEXU Robotics channel. If you get the 2 parking zones cleared with the 4 loading zones, and you get the 2 parks, that is actually 60 points. Because, of course, you get the other points from the blue parking zone and the second robot being parked. That would be 60 points. And so I do believe that earlier in the season we'll see teams closer to 100 points, because you have that second robot to work with, which will make it easy to clear out the second loading zone and park. So that's just kind of early season general strategy for both V5 levels and VURC. So let's kind of now proceed more into what this stream is about, of course, which is the CAD construction. So with the current custom plastics rule, of course, we have one piece that's going to be going on this robot, which will be used as a plate to make sure that nothing kind of gets under this initial nothing can get under this initial loading station here, or holding station, which actually, because I'll go ahead and delete this one because we no longer need it, because this is now our block holding station here. Block holding station. And let me see if I can actually find that video real quick to be able to shout out that team. Oh, maybe it was LTC Robotics. Yeah, LTC Robotics. Here they are. I'm going to cut audio for this to make it a little easier to see what's going on. So shout out to LTC Robotics for this. But they have believe it was Scraper Mech is what they called it. And so if we can get over to the loading zone. Yeah, so here's, I believe, the Scraper Mech from their Robot in 10 Hours that they were talking about. And this mech can basically just scrape into the goals, like underneath the blocks. And then as you can see here, it can then redirect the blocks to your intake that can just basically be up against the wall of the loading zone. Or you could even use something, I guess, to brace off it and make sure you don't run right up against it. That way you can kind of save your intake a little bit, because I'm pretty sure that's something that teams might, if they use the rubber band intakes, they might forget about, is that if you have your rubber bands, of course, sitting there spinning against the loading zone here, then that could wear them down and cause them to break, possibly even mid-match. And of course, if you're here on the lower lip, even with the height that they're for LTC, their intake is that if those rubber bands scrape against the loading zone, then that can of course wear them down, and like I said, cause them to break, and that is not a good day in the middle of a match. So yeah, let's see if we can get a bit better view of their overall robot. So yeah, here is their full robot, and the idea, of course, is kind of a conveyor hood mech, which does make sense, of course. But the only thing with this is that the conveyor is only single channel, and it can maybe fit 3 at a time on there. Where the idea here is that you can sit here and just sit at the loading station, load up your robot with one set of blocks, and then maybe even go to the other loading station and grab some of those blocks, with the potential to fit maybe 12 blocks in this robot, although I'm definitely not going to recommend that at all, because right now the robot is fairly long, but the Scraper Mech, I think, coming out in front is probably where you're going to get your extension and be at your max. Yeah, because it basically just extends out 3 inches, I would say, in front of the bot. So moving back to this loading mech, the idea for the bot is that you can, of course, load up each level as you go. So like once this first level, of course, loads up, then the next blocks will, of course, go up and over this first layer, because your intake will kind of load them up and over into, which, I mean, you could also have it to where a small stopper comes up here, and like even if this layer isn't full, the stopper will come out, or however you want to do it, like actuate out and cause the blocks to go to the top layer first. But that is, of course, for you and your teams to figure out, which would also allow you to possibly stop the blocks from going into this kind of holding mechanism, and then would allow the would allow you to hold more blocks here at the beginning and like the intake. All right, so moving on, for what I'm kind of wanting to do this stream is that I'm wanting to possibly rework the chassis, because with how this chassis is currently built, I do not believe that the block holding station will really fit within it. And so, let's see. Oh, that's why music wasn't going. So yeah, this is the block holding station, like I mentioned, and now we're going to kind of do an intake similar to the LTC robotics, although we're also going to take inspiration from the 9 Motor Gang bot and how they have kind of their rollers on their 12-hour bot. At the same time, we're possibly going to do a... let's see now. Let me see if I can find... oh, that was actually pretty good. Yeah. So here, kind of how they have rollers up along the front that can allow the balls to, or the blocks to come in and then kind of feed around. We're gonna instead make it more like a VEXU full volume robot, to where you'll have a wall of rollers on the front, and then the blocks can feed into the sort of holding bay, and then you have a lift that can raise the blocks up a little bit in order to get them into that top goal. And so let me kind of show you what I'm talking about here for the full volume robots. VEXU full volume. So no, not the Ben Lipper one there. Not this one. Kind of, does that one really show? So, no, this one doesn't really show, it looks like. But yeah, this is kind of the lifting mech like I'm talking about, to where the base will lift to allow the blocks to fall into the goals, because of course the balls, I keep calling them balls because that's kind of what they're shaped as. The blocks, of course, can easily slide in the goals this year. And so I think that them just being gravity fed, or just barely giving a slight nudge from the robot for them to come out, will easily be able to unload all of the blocks from your storage bay. Yeah, here's what I'm mainly talking about, kind of this intake design. Yeah, this kind of, well, maybe not with the not with the way that this is kind of spring loaded to be able to adjust to the different size blocks, because of course the blocks are only a single size this year for pushback. But maybe, is there a clean shot here? But yeah, you can definitely see where this is basically a wall of rollers that then allow the blocks to come up to the top. And for VEXU full volume, there was a separate how to explain this, a separate kind of sorting system, because the blocks were different sizes, so it was a bit more passive in separating the two. But I think that we can do something similar here with a wall of rollers if we want to add a block. So now these are not locked in place, so I'm going to come to the top, just kind of line these up, and I'm going to do fix you in place. That way these cannot move. Yeah. So what I'm going to do real quick is I'm going to do other documents. I think it was in. I don't know. Wait, crap. Where did I put it? Put it in Vex. Yeah, here it is. Okay. Oh wait, no. It was in inserts, other documents, owned by me. Yeah. Yeah, there it is. There we go. Yeah, I definitely know where I have all my files stored. Alright. So idea here is we're going to take this, fasten you to here, flip you to kind of bring you out in front here, and then you we're actually going to take and we're going to put you here centered with this piece. So we're going to use this kind of as our reference, possibly bring another one in here actually to attach to the top one. Flip you there. Yeah. So this is basically where our wall will come up for our intake. And I've kind of thought around as far as ideas for the intake, thinking of, okay, do you do it just different rollers, kind of how in IQ they did it, or because we have chain, is there a way to take the rubber bands and feed them around like a chain, and then just allow the chain to spin around a singular set of sprockets. So that's kind of what I'm having to figure out right now, mainly. But lengthwise, we're currently at how long? So to this piece, we're only at 12 inches. So now let's measure all the way from back to front. We're at 15.8. So you have about a couple inches, but that's where I'm saying like the sprockets can kind of come in handy to where you can feed to a smaller sprocket up front and possibly even make it to where, like with this, sorry, my dog is in the background. Give me a second. Alright, sorry about that. We are now back. So where was I? Yeah, talking about the intake. So for the intake, like I said, we got a couple of inches really here at the front, but that's where I'm saying that you can use a smaller sprocket probably. So for example, go back out here, go back out, V5, not gears. Is it under gears? I can't remember. No, it's not under gears. I was right there. Oh, chain. Duh. Yeah, here we go. So you could possibly get away with a... See, what did they use on theirs for LTC robotics? I think they used an 18 tooth, if I'm not mistaken. And of course, it's gonna take a minute for the video to load. Yeah, that looks like an 18 tooth that they used, and so let's go with an 18 tooth here for ours. And again, we're just kind of using this for size sake. Actually, probably multiple 18 tooths would be best. The thing is, though, the 18 tooth that they have is, you know, about 4 inches off the ground, maybe, or 3.5 inches off the ground to the bottom of it, because, of course, since the blocks are about 4 inches on their long side, then you need a bit of grip on the bottom. Alright. So come in here. Let's go 1, 2, 3, 4. Rotate these around, kind of give us a better idea of where everything will be spaced. And so let's go first with, let's measure from this point here, measure from here to opposite side is here. Here to here is about 2.5 inches. Or let's parallel distance. Yeah, we'll say 2.5 rounding up. Mic and stuff moving around. Alright, so with that, we can now slide you to about here, we'll say. Okay, yeah, I think there'll only be about 3 necessary. So we're going to delete you, actually. Where did delete go? I forgot. Delete, no, at the bottom. So I actually think I'm gonna go delete you here, and then we're gonna insert a 12 tooth maybe? Yeah, 12 tooth sprocket. Rotate you 90 degrees. Yep, there we go. And then you will be more like up here-ish. Now remember that these, of course, will be slid back a little bit. Wait. No. Actually, let's slide it out a little bit more. Okay. So that'll be 1. And then maybe 2 12-tooth sprockets. And you could potentially even make all of these 12-tooth, just for sake of kind of keeping it simple or similar to LTC. I'm going to use the same for the 18s here. Alright, so that's kind of about what you want this to look like. One thing that I am thinking of though right now is that really you just need the blocks to be able to get up this high, and then they'll kind of automatically go into this area here. So I'm actually going to find, where is that mate for you? I'm going to actually edit this, and I'm going to add an offset to where it kind of looks like the block is just cresting over this. So let's go with a Z offset of 2 inches. Nope, that is way too much. We'll go 1 inch. Okay, and then we'll maybe go 1.5 inches. Okay, so maybe closer to 1.5 inches. So I'm just going to leave that there. So really your intake could come closer to about here possibly. And again, this is very roughed in, not at all a final design, of course. Very roughed in, just kind of trying to give you guys an idea of what it may look like. Offset a little bit here. All right. So this is maybe about what your intake could kind of look like for the blocks. And another idea, of course, is that you could potentially go around and like load in, say, close this off and keep this as 4 blue blocks that if you're red, then the Blue Alliance cannot get to these 4 blocks. And you can basically just hold on to them the entire match. Or you could even, in going for the park at the end of the game, you could use those 4 blocks as a bit of a ballast to make sure that you don't, or even just during the match, you could use them as extra weight that you're carrying around to make sure that you're not as easy to push around. So that's just kind of another thought, of course, for this. And yes, I know that we're 30 minutes in. Apologies. But I think that's about where we're at currently for the intake, and I think that looks kind of good. I may potentially look into making, for example, this, not that one. Where did that one bot go that I had pulled up a minute ago? No, it wasn't one of those. Okay, I'm just gonna slide it over here then and look at our history real quick, see if I can find it. Oh, actually, I just realized music stopped playing. Okay. Here's that short. here's that shorter course of this robot being a lift bot. Wait, why are you not playing anymore? There we go. Okay, not sure why I didn't. Okay. So it kind of uses a chain lift design here, which we could potentially see, I may potentially use to kind of design here. Now, I do recognize that this means that it'd probably be better to go with a 4-motor chassis as compared to how I built this one to be a 6-motor. Thinking about it, you can of course get away with a 6-motor drive this year if you go with the 5.5 watt, which I think would be good. Although really going with a 4-motor 11-watt drive would be better than a 6-motor 5.5 watt. So I think that I'll just knock this down to 4 and then move on from there. So I think what I will do is that you can remove individual components from here, right? Yeah. Okay. So I think that I'll just save these as like a version 1 and then come back and do a version 2 a little bit later. But right now I kind of want to focus on the intake and getting it right. So what we're going to do first is I'm going to insert, come back out, V5, go to structure here. And now to kind of figure out which pieces we want to use, kind of comes, you know, don't really need that right now. But I think we're going to go C channel again, then go 1x2x1 aluminum, and then 12.5, actually let's go 15. The reason being that 15 inches will give you a little bit more space to work with here. And so let's go here. And I want to line the bottom of this one's plane up with the bottom here on this plane. So I'm going to go here with planar. And I'm going to go here, this plane. And I'm going to go here on this one. And that is the right direction. So we're going to go here. Then just for the sake of keeping everything a little easy, I'm going to go planar this face, planar to this face. I'm going to flip it. And now this can slide. Oh, I forgot that is not locked in place. That is not locked in place. Ah! Actually, wait, where's the fasten 10? Wait, why are you not working? Wait, does it not have... Okay, that is very confusing. Okay, so we're gonna go... like U to U, and then okay, so now is that locked back in? Okay, yeah, now it's locked back in place. Okay, working nice. All right, so we're gonna slide you over now and just kind of see if there's anywhere where these somewhat line up. So I'm gonna go maybe here, maybe shift you a little bit to here, and then shift you a little bit up to here. Cool. And now I think what I do is I go measure to see what kind of distance might be between these two and what kind of distance I need to add. So 3.66, 0.668, and then what if I go 0.625? I think is 5/8, right? 0.625 times 8. Yeah. So I think I need to figure out how to do a custom spacing of 5/8 here. So let me see that real quick. Yeah. So if I go to, hold up, so I need to insert, oh no, I need to go to intake first. Because width-wise, I want this intake to at least be, how wide? We'll say at least 5.5 inches. So I might make a intake that is not too terribly wide, but wide enough. So let's make a 6.5 inch wide intake. So I'm going to delete all this that I had from before. And we're gonna go, what size did I make the C channel here? I think it was 15 inches, right? That might be way too tall. Oh yeah, I forgot, because this is 20s that I've downsized it to. So yeah, these are way too big now. So I'm gonna go with a 25. Yeah, I'm gonna go with a 25, because then if we have any 25s, then you can just use those instead of having to cut them. So let's go 12.5 here. Whoop, wrong one. 12.5 inches here. And we're gonna go 1x2. Generate. Let's go 2 of them. Check. And let's go. So, oh no, the origin is just there. Okay, we don't have reference planes. Yeah, that's fine. So let's go rotate up 90. Rotate up 90. Rotate around 90. Then rotate around 90. Alright. Now I need, actually first, VEXU. That way I can go fastened mate. Come here. To here. Offset, nope. Offset. And then I'm gonna go 6.5 inches on the Z-axis. I'll borrow my headphones real quick. Six and a half inches in the Z. That should be, oh, nope, needs to be negative 6.5. Negative 6.5. There we go. So now check. And we're gonna also planar mate these. Actually, no, they should. If I unfix this one, they should. Yeah, okay, they completely moved together because of the mate. So now let's slide them up to here. And slide them over this direction. To semi-center this a little bit. Slide this over a little. Okay, I think it's, yeah, that should be, or fix you and use you as a reference point. Okay. So now, let's just slide this back over just a tad. No, hold up. Okay, that's a little better center now. Alright. Now we're going to move on to, yeah, you're fixed. Now we're going to try and get our sprockets kind of in place for our intake. So this first sprocket is a, oh, I just realized it is a little lower actually. So we need to account for what kind of a height difference are we looking at. 0.375, 3/8. Actually, I think this whole thing might sit 3/8 above the ground. I'm not gonna have it probably scraping the ground to make it a little easier. Because let's say this is the floor. Then from this bottom edge, measuring along the Z, that's about 3/4 inches. Yeah, that's fine. Because that'll actually sit about 1/4 inch above the middle, the middle portion, or the lower center goal. Good grief. So now, shift around real quick. Looking at where this is, we're going 5, 6, 7, 8. So we're going to the 8th hole from the bottom. I think actually this can be shifted over a little bit more. Definitely the 1/8 that it was going to be. But what is it now? 3. Okay, I think 3.5 is probably going to be the ideal, if I had to guess. Alright. Actually, yeah, that looks like it'd be better there. Alright. So now we're going to go with a... Do I stick with an 18 or do I just go with the 12s? Let me just try 12 down here real quick. So if I go with 12 down here, and instead of the center being here, shift it down 1, shift it over center, probably like right here-ish. Then that will probably eliminate how far off the edge? So let's say from here to the front is like 17 and a little over 17.25 versus okay, that is 18. So we're going to actually delete the 18.2s here. And then use the 12.2s. So we're going to bring you down here. Here's the second one. Yeah, second one. So I'm going to use you. Bring you a little closer if possible. Offset you just slightly. Probably there will be fine. Because let's go to this one now. If we take you, I'm going to let's edit you. Because what I want to do is, that's the Y direction. Alright. So let's go offset Z 1 inch. Okay, that shifts you 1 in. Now let's go Y 1 inch. Okay. So that is a little too far. Let's go 0.75 inch. It's a little closer. I think what I may do is I might actually like take this piece and kind of gouge out the top a little bit to make it a little easier for it to roll in. But looking at this, the blocks may actually need a little bit more coaxing to go in. So then we're going to go there, and now rolling up here. Yeah, I think I'll space you there. And then maybe another one like right here-ish. Because it doesn't need to go all the way straight up. It just needs to be able to come over. I mean, I guess if you do have blocks in... No, because when you go to raise this up, then they'll maybe get stuck. Alright. So... let me take a look at this again real quick. Yeah. Alright. So in the center, we go 5. Yeah, 5, 6, 7 up in the center. And then you go 1, 2, 3, 4 more. Okay. So for intake, I'm going to hide you. Come back out. Go sprocket, 12 tooth. 2, 3, 4. Let's just go a 5th one to make sure. I think that's gonna be plenty. 1, 2, 3, 4, 5. Rotate 90. And now 1, 2, 3, 4, 5, 6, 7, right? And then 1, 2, 3, 4. So let's just kind of keep that pattern going. Yeah. Alright, so that's roughly where the... Let's go you there. You there. You there. Oh, no, rotate. There we go, slide back out, and you slide back out. There we go. So now we'll go block holding station. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Alright. Yep. So now for these, they'll of course get rubber bands put around them, but as with LTC robotics, robot, you can thread the rubber bands around, and you could send it to a smaller sprocket on the outside, or I think you can actually still use these sprockets as they are, but we're not going to do that for this. So I'm just going to take all 5 of these. Bring them out about 1 inch. Yep. Now, I think 25 is still going to be too tall, and so I think we're just going to take off this top one here. And now let's go and actually, I'm going to use an 18 up top. That's where I'm going to use an 18. And now, rotate 90. And so maybe, just maybe, with the... we're going to edit this one. We're going to go 1 inch. And then Y, we're going to go 0.25 inches. maybe go 0.375 inches. Yeah, I think that's pretty good to say. So I think that you can get away with a 18 inch or 18 tooth on top probably. So what we're gonna do is you're gonna slide over to like right here, and then you will just be powered by a sprocket from the bottom. And yeah, I think you'll be fine. Actually, maybe bring you down one. So we're actually gonna bring in come in here, bring in another one, and just kind of rotate you 45. Come in line with these. And I'm just gonna adjust you up and around wherever I need you to be. So, ooh, that actually might be fairly close there. So I think I might actually move you back out to, or I'll move you back up to where you were. Because now, yeah, I think maybe move the lip here a little bit. And then when it gets up here, yeah, you'll kind of have to like grip along here, and then, yeah, you know what? I am thinking just delete this one and then go insert another 12 tooth here. Yeah, 2 more 12 tooth, I think. Then go here and here, rotate 90 degrees. And just kind of up to here. Ish there. Go there. Yeah, go there, and then yeah, it looks like it should come up here, and then it needs like a final kick kind of to make sure that it goes that way, which may just be like having this sprocket here to make sure that it gets kicked that way a little bit. Yeah, I don't think having this one there will be good, but that one there looks like it should come up, and then kind of just a final little oomph in order to make sure that it does go that way. Okay. Keep in mind that this is all just theory, because you can do everything in CAD that you want, but until it's actually built, you don't know if it'll work. So, we're still going to just go ahead and CAD it up anyways. Now, do only need the 4. So 1, 2, 3 spaced evenly, and then the 4th one I think knocked down to, I believe it was here, if I'm not mistaken. Let's kind of come back to here. Yeah, so it looks like they would just barely miss there. Alright. So, now that we have these, what we are going to do is yeah, I think what we're going to do is just go ahead and mount these to the respective positions. Wait, shift. Alright. So that's 1, 2, let's get 3 going, and let's get 4 going then. And then this one is going to be the oddball, and it's going to be offset to here. Good deal. That's looking good, looking good, looking good. Now, for figuring out... motor probably could be either on... probably bottom one would actually be best. And then you can have like one set going across here in order to get these going, and then cross over to the other side in order to get those spinning. And then the top one can of course be hooked up over here. So let's see now. Yeah. Alright, so I think we're going to go insert. We're going to add in another 4 12-2 sprockets. So let's come here real quick. Somewhat try to align them in plane with one another. And we're going to go 1, 2, 3, 4. Rotate them all again 90 degrees. And we're going to go 1 is roughly here, 1's roughly here, here, and here. And I'm now going to select all these and slide them back out of the way so that I can then make this one visible again. And I'm going to remount all of them, fasten them all to there. Mainly just fastening them for now to... Oh, hold up. There we go. Alright, now swap. Shift around here. And again, make sure this is a V5 bot that I'm mainly trying to design. For VURC, of course, this is not close to the design that I'm planning on us building. So if that's what you're hoping for, then I'm sorry, but this is mainly for like middle school and high school where they have a bit more limitations. And this is one of the reasons why I'm going to swap it to a... Actually, now that I think about it, you could probably keep a 6 motor drive because you could power this intake with just a singular motor. So we'll explore that a little later, or I'll explore that maybe more on my own to see if I can get it to work. But we'll see. Alright, so now we have this. You have... I think that I'll actually go ahead and add the motor in potentially for this. So let's go ahead, insert. Then V5 parts, electronics. I think we'll just go with a regular 200. Or you can maybe even get away with 2 5.5 watts potentially on this. I think that's what I'll go ahead and do. It's just 2 5.5 watt motors. Yeah, for now I'll just go with 2 5.5 watts. But I may swap that to either a singular 11 watt or to 211 watts possibly later on. Alright. Let's go there, flip. That's the right side. So now we're going to go here, flip, rotate. That's the right side, right? Yep. Okay. Now thinking about it, I might need to make this a little bit wider because of how far apart those faces are. So let's go with, instead of 6.5, because these are how wide currently? That's nearly 5.5 there. Yeah, I'm gonna go 7.5. Widen it a little bit more, that way I can fit the other sprockets on the inside here and give a little bit of space for them to breathe. So let's go ahead and I'm going to insert the 6-tooth sprockets. Let's go 6-tooth. Where are they at? Where are they at? Where are they at again? Here. 6-tooth. So I need 1, 2, 3, 4, 5, and 6. So I need to do undo. Yeah, so I need to edit you. Actually, here. Suppress you, and then suppress you. So that way I can slide y'all off. And now attach these. Attach you there, and then attach you there. Oh, slide down a little too low. Here and here. And now edit. Instead of attaching to the C channel there, we're going to go here, check, and then unsuppress. Yep. Then go back to your unsuppress. Yep. Do the same thing over here with these two now. That'll be, so that was what, 2 and 3, 4, 5, 6. So that'll be 7 and 8 now. 7. Yep. Suppress and 8. Now you center there, so now you have center there. Flip you again, center here, then notch right here. Flip you again. Now we're gonna go edit 7, delete you, yes, and then I'll fix the spacing here in a sec for those. Or well, actually I can leave a little wider on those. Yeah, I can leave these two wider up here. Now, with that, we're gonna go. Now, where was I? Oh yeah. So now, unsuppress 7. Oh, voice is cracking now. Check. And unsuppress. Gives you that. Then now I need 3 and 4, right, again? 3, or no, 4 and 5. Yeah, so 4 and 5. Suppress. There's 4, there's 5. Then we're gonna go fasten again here, and it was, yeah, center where the notch is at. And then we need offset to here, except down one, right? Or no, on that level, yeah. Edit here. Check and unsuppress. Edit on this one. Then do the same thing. There, check, and unsuppress. Alright, so now I'm going to kind of add some chain here just to make it a little easier to determine where the chains are going to all connect to. I do have to determine, though, center distance between this connector and this connector. 1.768. Okay. Oh, no. 1.767767. Okay. So we're going to control C that. And then that's probably the first chain that I'm going to make here. And this is 6T or 9P chain. So now I need U, inches, enter, generate. What? I thought it was, yeah, 1.76. Yeah, 1.76. Hold up. Let me pull up my notes real quick. That way I can add this here. It's 1.7. 767767. Generate. There we go now. Pull this out. Of course, it's going to be a little bit off, but we don't mind that. Now these two are going to be 2 inches. They're both 2 inches. Yep, 2 inches. So now we're going to go configure 9P chain again. Change this to 2 inches. Generate. Basically just adds one more link. Here and here. And I'm going to now slide U down to here. Okay. So we want to revolute mate right here to here. There, and then revolute U to U. There we go. Okay. So now revolute U to U. Revolute U to U. And here's the true testament now. Will you comply? No, you will not. Wait, what did you do to that one? Okay. Revolute mate here to here. Check. There to there. Why are you not? Okay, we're just gonna go Control Z. And then we're gonna go forward one to where this is there. And then we're just gonna go as close as I can get it. Probably right there if I had to guess. And then now we're just going to fix. Yeah. So now you cannot move. I think that is where okay. So now I'm going to add a bit more detail to this. So we're going to go how do we want to play this now? Oh, I gotta stop. Actually, first thing, let's see if I need to expand this anymore first. 4.4. Hey, there we go. So still plenty wide. So I think 7.5, or did I extend it at all? Nope, still 6.5. So I think 6.5 might actually be the width it needs to be at. And actually, these look like they can shorten. So let's actually go here and here. Change configuration. I'll actually go 10 inches here. 10 inches. Change configuration again to 10 inches. Good. Good, good, good. All right. So looking at this from the front, then we need shaft collars, which I'm still going to use the rubber shaft collars. Didn't get thrown in here, did it? No. I'm already forgetting. It's been a couple weeks since I've actually used them. No, not there. Bearings and collars. Here we go. Yeah, rubber shaft collar. Here we go. Alright. So, 1, 2, 3, 4, 5, 6, 7, and 8. Now we're going to go here. And for now, I'm going to just act as though I'm using low strength shaft. Well, at least for this one, I would have to use a low strength shaft on it because you got the EXP motors here. May change that again to the 11 watt motors, and so yeah. So yeah. Yes, I know this is a bit of the finer detail work, but this is what I like to take a little bit of pride in my work, so we're just going to add these last few details here for the intake. Know that this won't be quite finished, but at the very least, the last shaft collar here. Alright, so now we're going to just exit out of that. Now, coming off this, I think we're going to just have shafts left. Oh, and bearing flats. Forgot about bearing flats. So bearing flats for this one's going to be little... through there. Yeah, okay. That's going to be a little bit finicky, but I'll get it figured out. So, 1, 2, 3, 1, 2. Okay. Yeah, down through here is going to be a little bit. And again, these may, I'm probably going to readjust some of this stuff to where like the screws will actually be able to fit and stuff. But I mean, you could even like put a single screw probably through this one here and it'd be fine, so that's not that big of a deal necessarily. Yeah, that won't be too bad. Alright, so let me take a few minutes real quick to put some of the bearing flats on here. Let's see. So I need... Where is flat bearing? 1, 2, 3, and 4 on that side. 1, 2, 3, and 4 on this side. And we're just gonna go... Yeah. Take this one, put you there. Ooh, actually no, we're going to Control Z. Whoops. In that case, then what I'm going to do is I'll take the motors. Let's find their fastens real quick. Is that the motor fasten? That was the question. Where did that end up? Suppress and press. Pull these off real quick. Then let's get the bearing flat situation handled now. So I think I'm gonna go fasten you to you. Then I think I'm gonna go you to no, okay, you might have to shift down one potentially. Actually, let's just center all these for now, and then I'll readjust them later. So fasten mate here, just make it easier to figure out real quick. Center you there, and then you here, center you there, you will go here. Wait, why are you not? Okay. And then, ooh. Actually for you, I'm going to take one of the low profile bearing flats. So I'm gonna go slide here. Then delete you. And delete you. And slide you up. That way I can see easier. I want low profile real quick. Yeah, low profile here and low profile here. And then we're going to... No, oh, I thought it was slider for a second. Yeah, okay, so I might need to swap that one out with a low profile as well. Okay, that can happen. That one, and yeah, we're gonna go here, delete, then delete you. Now I need 1, 2, and then I need another 2 over here then. Well, it's kind of just better to start off with them wherever you can. And now slide up. Fastened. Yeah, let me just slot center over that. And then top hole here, over here. Yeah, there they go. Now let's go there, for down here. Flip you. Come here to this one. Grab this one. Go here. And then grab the last one here. And you go onto here. Flip, spin, spin. Cool. Now, I remember now which ones you go on. Right here. So in that case, we're going to slide you two down 1. That way we can get the motors on real quick. Then slide back up to... There it was. Edit. Then we're going to do you, and then now slide. Edit. Check, and then unsuppress. Whoops, need to flip it over. Edit, and then flip. There we go. And now this last one here. Edit. X. There. That's pressed. I need to flip you over too. No, pretty good. Alright. So I think we're just going to call this one there for now. That's pretty much intake, concept, and start of a prototype design done in an hour and a half. And so for tonight, I think I'm just going to end it there. For anyone that's still here, thank you for watching. And I hope that you got something useful out of this. Again, main thing that we're designing around is this block holding station with the hope that we can can get at least 8 in the holding station, and then possibly 1 to 2 here out in front. Possibly even figuring out a way to fit 2 or 3 up here in the kind of chamber, I guess, before the holding station, which would then allow you to get up to, I believe, so that'd be 8, 3, and 2, so that'd be 13 blocks that you could easily control and not just have kind of sitting in your robot. And so if you find this video useful or inspirational to your robot design, please feel free to comment and like our channel and subscribe as well for our future content, because I will be continuing more CAD streams as we go later on into the season for design concepts, and I'll also be starting some IQ designs starting here in the next couple of weeks potentially. But if you have any thoughts, feel free to share. And this has been the AAMU1 CAD Stream 3. So thank you guys, and go Bulls.